5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
This is About Space, America's return to space, with news and information on our U.S. space program. Is your host of About Space, David Denault.
Welcome, and thanks for joining me today. There's been so much news about getting core samples from Mars and bringing them back to Earth, but sometimes we forget about our frozen outpost in Greenland and Antarctica, where scientists drilled an ancient ice core dating back more than 9,000 years, and a story dating back to 775 BC. I'll share those amazing details and a special report next, as America and the world is listening to About Space Today. Ever dream of an island getaway at an all-inclusive resort? Or going on an island-hopping cruise to multiple island destinations? See sun-bleached beaches and swim in the azure waters of the Caribbean Sea. Call today for your special discount prices to your island getaway. This is a special offer for About Space by calling 877-747-8631. And let's go and explore the islands of the Caribbean. Welcome back. An international team of researchers announced the discovery of fallout from an extreme solar storm entombed in ancient ice. Well, ice cores are long cylinders drilled from the ice sheets and glaciers, frozen time in capsules that allows the scientists to reconstruct events in the distant past. Here's more on the discovery of ancient ice.
An extremely powerful solar storm pummeled our planet 9,200 years ago, leaving permanent scars on the ice buried deep below Greenland and Antarctica. A new study of those ancient ice samples has found that this previously unknown storm is one of the strongest outbursts of solar weather ever detected and would have crippled modern communication systems if it had hit Earth today. But perhaps most surprising, the massive storm appears to have hit during a solar minimum, the point during the sun's 11-year cycle when solar outbursts are typically much less common, according to the study. Because of this unexpected discovery, the study researchers are concerned that devastating solar storms could hit when we least expect them, and that Earth might not be prepared when the next big one arrives. Study co-author Raymond Muscular, a geology researcher at Lund University in Sweden, said in a statement, "It is of the utmost importance to analyze what these events could mean for today's technology, and how we can protect ourselves." Huge gouts of plasma and magnetic field known as coronal mass ejections, CMEs, which surf across space on the sun's ever-gusting solar wind. If a powerful CME passes over Earth, it can compress the planet's magnetic shield, causing what's known as a geomagnetic storm. Mild geomagnetic storms can damage satellites and interrupt radio transmissions. Severe storms, like the Halloween storms of 2003, can cause widespread power outages across the world and permanently damage electrical infrastructure, such as power transformers. Today, satellites can monitor solar outbursts directly. But finding evidence of ancient storms requires some atomic detective work. In the study, the authors analyzing several cores drilled in Antarctica and Greenland. Cores from both locations showed a remarkable spike in the radionuclides beryllium-10 and chlorine-36 around 9,200 years ago, indicating that a powerful solar storm swept across Earth at that time. Further analysis of the cores showed that the storm was particularly powerful, perhaps on a par with the most powerful solar storm ever detected, which occurred during a solar maximum between the years 775 BC. According to the study authors, it is now essential for researchers to detect more ancient, extreme storms in the ice core and tree-ring records, to determine if there is some sort of pattern beyond the sun's 11-year cycle that dictates when the most extreme storms will occur.
And to predict what the sun may unleash in the future, well, NASA has just selected two science missions, the Multi-Slit Solar Explorer, or MUSE, M-U-S-E, and the HELO-SWAM. And that will be to improve our understanding of the root causes of solar instability and the constantly changing space weather environment. Two different kinds of core samples from two very distant and different planets, yielding thousands of years of history. Join Don Meyer this Friday for another America in Space program and have your family and friends join us each week. Follow us on Facebook at aboutspace.today for launches and landings. And to all our listeners around the globe and here in the U.S., thanks for joining me today. I'm David Denault, and this has been About Space Today.